Welcome everyone. In this video, we are going to label our data using BART MLNI. So BART MLNI is a transformer by Google. So you may be wondering what a transformer is in the first place. A transformer is nothing but a specialized deep learning model which specializes in sequential data. So what is an example of a sequential data? All the sentences in English that we use are a good example of sequential data, because to make sense of the next word and words that follow the word, we first need the context of the previous words. Like, you need every word in the sentence to understand the sentence properly. So that's what sequential data here means. So for that, we are going to use this model developed by Google known as BART. So for that, we are going to install this Python package first, which is known as transformers. So after, from this transformers, we are importing pipeline. So what is a pipeline? Pipeline is nothing but like a full data flow in which you put in data in this pipeline, and it takes your data, it pre-processes it, it changes it. For example, here we are providing text data. So what a pipeline will do, it will take your data, it will convert it into numeric format, because computers only understand numbers and they cannot make sense out of words, and it will take this numerical data, it will feed this data, numeric data, into our model, and it will again convert this numeric data into text data that we actually want. So what a pipeline basically does is, it takes in input from the user, it performs all the necessary steps that are to be performed on your data, it applies the models, and it gives you the human readable results again. So here we are using a classifier, so which is known as BART large MLNI. So this model is a pre-trained model. Again, we are using pre-trained model because it does not take up that many computational resources, and we don't have enough time to train such huge models. So here, for an example, our classifier takes in two inputs: sequence to classify. Now sequence to classify just means the sentence that you want to classify. Here I am using the word classify, but what we are actually doing is, let me tell you in a few moments. We are passing in a statement to our model, and after that we are passing in the tags, whether this statement may be related to travel, whether it be cooking, whether it be dancing. So if you read this sentence, I like to make pasta, it's very clear that it's related to cooking and not dancing and travel. So if we are passing these two inputs to our classifier, one is sequence to classify, one is candidate labels. So it is correctly predicting that I like to make pasta is more related to cooking. As you can see, the score is 99% here and like in 0.0% here, because it's related to cooking. Now if we take another such example, most car accidents happen because drivers aren't paying attention. So here, uh, as you can see, these belongs to two categories. One is travel and one is health. Because it is also related to car accidents, and travel because it is also related to cars. So we are passing in again these two inputs. One is the sequence to classify, which is our string of characters, which is our sentence, and second is the candidate labels, like the possible labels for this sentence. So as you can see, the top label which emerged was travel with 94%, and with 0.4% other is health, and then is dancing. It is quite explanatory that dancing was in the last, because this statement is not related to dancing, it is more related to travel and then health. Now what we can also do with this models is, here we are only predicting which which labels are most appropriate for a statement. What we can do with this model is, suppose I am giving you this statement, I am not giving you any labels. This model can also give out labels, like this is related to cars, this is related to accidents, right? So let's try doing it. Let's replace this travels with accidents. Let's see if it is a okay. Let's see if it's a valid tag. Yeah, as soon as I included the accidents in it, it is very clear that this statement is related to accidents. So the accuracy jumped from 94% to 99%. So that was it for this video, and thanks for watching.